So 2's complement is similar to 1's complement. The minor difference between 2's complement and 1's complement is that once you swap the zeros with ones and ones with zeros to represent a negative number, what you would have to do after that is add 1. So remember, and you know what I'm going to do here? I'm going to just copy this. I'm probably going to change the values here. Let me say, actually, it's fine. I can keep everything the same. I'm going to say value 4-bit of 4-bit 2's comp. And this is 4-bit 1's comp. And this is 4-bit sign and magnitude. And this is 4-bit unsigned. And this is just decimal. Can't represent negatives. Okay, that's fine. Let me do this. Okay. So when we have a positive number like this one, the 6, it's going to look the same way. Comp, let me just do a comp here. It's going to look the same way, or it's going to look the same. So that would be that. When you have a negative number, you're going to do something similar to what you did in 1's comp, except that you want to add 1 after you swap. So you're going to start with 4. That's 4. You're going to swap. So that's going to be 1, 0, 1, 1. And after that, you're going to add 1. And if you add 1 to this, you're going to actually, I'm going to just show you. Let's say we have a 1 here. 1 plus 1, there's going to be a 0 here. Excuse me, 1 plus 1, there's going to be a 0 here and 1 here. 1 plus 1, 0, and there's a 1 here. 1 plus 0, that's going to be 1. So really what you're going to end up with is that. If you take this and add 1 to it, you're going to end up with this. And that's how -4 looks like in 4-bit 2's complement. Okay, 12, I'm going to tell you here that you cannot represent it. We can talk about the range after, but you probably can guess that -12, or rather 12, is rather outside the range. Of course, -12 is also outside the range. And -1, I'm going to do the same thing. I'm going to say, I'm going to start with 1. Then I'm going to swap. And then I'm going to add 1, which would be this. Let me pause here and ask if anybody has any questions about anything we covered. Okay. So let's go back to the slides. So here's an example. Using 2's complement representation, represent the decimal 3. Well, 3 is positive. We can just represent it in 4 bits using 2's complement. It should be the same. So because 3 is positive, we simply convert that as if it was unsigned. So we don't think about the negative. We just convert that to binary. Here's -6. We did -6. Actually, we didn't do -6. Let's do -6 here. So that's -6 here. -6, of course, cannot be represented here and unsigned. For sign and magnitude, we use the most significant bit for the sign, and then we say 6. That's how it looks like. For 1's complement, we start with 6, which is 2 plus 4, and then we swap. For 2's complement, we start with 6, we swap 1, 0, 0, 1, and then we add 1. That would be 1, 0, 1, 0. So this would be -6 this would be -6 in 2's complement. Okay, So again, we start with 6, and that would be this. We swap, and then we add 1. We end up with this. Okay. So here, we're converting this to decimal. So do you want to think about that for a second? Do you want to have a discussion? We can have a discussion. And by discussion, I mean some sort of, brainstorming for a second. And we can, what do you think? Let me first hear your thoughts. So this is the question. Convert from 2's comp to decimal. What do you think we should do? We should do the opposite of what we did. Okay, so Anthony, how did you do it? Do you have an algorithm? Do you have a step-by-step? That's what an algorithm is. It's a step-by-step description of kind of, a procedure to find the solution. Okay, so subtract 1, swap values. Okay, swap and convert. Okay, I like what you guys are doing. I think you're kind of, your both solutions are the same. Easy to take away 1 here, could be harder if the final digit is 0. That's actually a good point. It might be more difficult in other scenarios. I love the discussion. I love where the discussion is going. We come up with a solution. We're also saying that it's not very easy in some cases, even though in this case it's easy. I like everything that we're saying. Let me tell you where your solution came from, and you probably already know that's how you came up with it. But if you want to convert decimal to binary, of course, right now we're talking about 2's complement. We want to do the following steps. If you want to convert decimal to binary, and let's say negative decimal to 2's complement, first you convert the kind of absolute value of the number to binary, and then you swap the ones with zeros and vice versa, and then you add 1. That's really what we're doing here. This is what we did when we did the -6 and -4. So we started with 6, then we swapped, which is really what we do in 1's complement, then we add 1. So we start with the absolute value, which is 6, and then we swap, and then we add 1. Now, if you want to go the other way around, if you want to convert from 2's complement binary to negative, let's say it's a negative number, then you want to kind of do the reverse, and you want to essentially swap the operations, not just in reverse. So add 1 is going to be subtract 1. Swap the ones with zeros is going to become swap the zeros with 1s and vice versa. Essentially, it's the same, right? So swapping 1s with zeros and zeros with 1s, if you want to do this, the opposite operation, essentially the operation that's going to take you back to where you were before you did this, it's going to be the same thing. If you swap again, you're going to end up with where you started. So that's really, so doing this is going to be the opposite of this. And of course, we convert the binary to kind of the absolute value. Essentially convert the unsigned binary then to kind of decimal, then add the negative sign. It's actually that. I mean, we don't have to dwell on this, but what you're seeing here is pretty much actually the opposite of this. Now let's talk about your answer, which is -3. And let's try to do this to that and see if that'll work. So the first thing is we need to subtract. So if you subtract 1 from this, I'm going to say subtract 1. So that's going to end up with this. And then you're going to swap. I'm just going to say swap. So that's going to be 0, 0, 1, 1. And then you're going to convert that to unsigned. Convert, I'm just going to say convert, and that's going to be 3. And then you add the negative sign, that would be -3. This is actually correct. So this is actually correct. So subtract 1, swap, and then convert to unsigned and add the negative sign. Now, of course, something that I want to mention before I proceed is that the number could be positive, right? I mean, if I say convert this 2's complement to decimal, that's going to be 1. The answer is 1. So let me just say one thing here, and I'm going to pause and see if you have any questions. When you convert from 2's complement or from 1's complement or from sign magnitude, if you convert from 2's complement, 1's complement, or sign magnitude, what you're going to do is you're going to look at the most significant bit. And if the most significant bit is 0, then that means the number is positive, and you simply convert it without doing any of the operations that we did here. So if I ask you to convert, again, I'm going to say it one more time and then pause if you see if you have any questions. If I ask you to convert from 2's complement, 1's complement, or sign and magnitude to decimal, the first thing that you should do is you need to determine whether the number is positive or negative. That's the first step. And you do that by looking at the most significant bit. The most significant bit will always tell you whether the number is positive or negative. And if the number is positive, meaning that there's a 0 here, you simply convert it like this one. This one becomes 1. When the most significant bit is 1, that means it's negative, and that's where you would have to kind of flip or subtract 1 into its complement, or look at the magnitude and add the negative sign in sign and magnitude. So in this case, when you have a 0, then you simply convert that to unsigned, and that will be the correct answer. Let me pause here and see if you have any questions. Give me a thumbs up if that makes sense. Okay. All right, perfect. Now, of course, once you see a 1, once you determine that it's negative, then you have to do something. In 1's complement, you simply swap. In 2's complement, you subtract 1, then swap. Of course, you don't want to forget the negative, convert and add negative sign. And of course, in sign and magnitude, you simply convert. You don't swap. There's no swapping. You simply convert the magnitude to unsigned, and then you add the negative. So depending on the representation, there's different procedure. Now, to go back to what Anthony was saying, which was very important, is that, I think it was Anthony, is that subtracting can be rather annoying. We don't like to subtract. In this case, subtracting was easy because we have 1 on the least significant bit position or location, and it was easy to subtract 1. We can just replace that with 0. But in some cases, it's kind of annoying to subtract 1. And subtracting 1 means, and this is something that we can think about for a few minutes, but subtracting 1, if you take the subtract 1 and you decide to do it after the swapping, then that subtract is going to become add. And let me demonstrate that. I don't want to prove it, but let me demonstrate it in a few examples. So if you have this sequence, and I'm going to kind of subtract, then swap. Of course, subtracting is going to be that, and swapping is going to be 1101. That's subtracting, and that's swapping. Is that good? Are we on the same page? Let me pause here and see if you're on the same page. So I'm just giving you an example of something that I want to subtract one from, then swap. Subtracting one is going to give us that. Swapping is going to give us that. This is equivalent to swapping, then adding one. So I'm going to actually do the same thing here. I'm going to put it here. So I'm going to swap. So I'm going to say 1100. That's swapping. And then I'm going to add one, and I would end up with 1101, and that's adding. So instead of subtracting and swapping, we can actually do the swapping and then the adding, and it's really the same thing. And the reason why we like this more, we like swapping than adding, because nobody likes subtraction. Nobody likes subtracting. I don't want to be subtracting from binary. Imagine subtracting one from here. I mean, that's going to be confusing. I have to put a 0 here, and then I have to put ones here. So it's kind of, it's not super convenient. Of course, we can do it if we have to, but why do it if we can do addition instead and simply do the swapping beforehand? So if you want to convert from 2's complement to decimal, again, the first step, let me summarize that here at the bottom. The first step is we look at the most significant bit. If it's 0, then we simply convert the number, treating it as unsigned. Kind of just simply convert it, right? Now, if it's 1, meaning negative, we do the following steps. We swap first. Let's just do A. Swap the zeros with ones. I think that's what I should do when I write zeros and ones. It actually, the proper way to do it would be this, I believe. Even though it looks odd that yeah, in this case, actually, it'll be 2's complement. But here, when we say ones and zeros, yeah, that would be the right way to do it. But with 2's complement, you want to keep this apostrophe. Okay, so to going back here, we swap the zeros with ones, and what we do is we add one, and then we simply convert to unsigned and add the negative sign. Rather, convert to decimal, treating it as unsigned, then add the negative sign. So that's it. We can do a few examples here. Let's actually do a few examples. I'm gonna just do one for 2's complement. So let's say 2's complement, and let's see, there's a question here in the chat window. Wouldn't we still need to remain mindful of the most significant bit? For example, 1101. Let's do 1101. So of course, right now we're converting from 2's complement to decimal. That's okay. We can do that. Righty. So we look at the most significant bit. I mean, that's actually what we're doing anyway, converting from binary to decimal. We look at the most significant bit. That's going to be 1, which means it's negative. We swap. So we end up, after swapping, we end up with 0, 0, 1, 0. And then we add 1, we end up with 0, 0, 1, 1. And then we convert that, treating it as unsigned. So that would be 3 if we treat it as unsigned. And then we add the negative sign. So it would be negative 3 here. Yeah, so that's, yeah, we don't want to forget this one. This is the most, it's not the most important, but it's very important. So let's do a few examples here. Let's do 1, 0, 1, 0. I'm going to actually do an interesting example here, which is 1, 1, 1, 1. And maybe another interesting example, which would be 1, 0, 0, 0. That would be an interesting example as well. And let's do 0, 0, 0, 0. That's actually more interesting than the ones, but that's okay. Let's do all of that. And if we do all of that, we can probably stop here, even though there is actually a few things that I need to add, but maybe we can do it tomorrow, just because we're kind of out of time. Decimal, let's just say decimal. Okay. So again, this one we did here, right? So this one's going to be negative 3. What we did is we looked at the most significant bit. It's a 1. All of those are, at least most of them are ones, except for this one. This one's actually not that interesting right now. Yeah, this one is actually going to be interesting. This one at this point it's not, but we can keep it. So we look at the most significant bit, which is in this case 1. That's negative. We swap. Let me actually do something. Let me say after swapping. So after swapping 0, 0, 1, 0, and let me say after adding 1. That would be 0, 0, 1, 1. And of course, that would be 3. And because of that, we don't want to forget the negative sign, and that would be negative 3. Let's look at this one. After swapping 0, 1, 0, 1, after adding 1, 0, 1, 1, 0, which would be 6, and then that would be negative 6. Is that good so far? Give me a thumbs up if all of that makes sense. Okay, let's do this one. We're going to swap 1, 2, 3, 4. We're going to add 1, 1, 2, 3, 1, and that's going to be 1, and that's actually negative 1. So this is kind of interesting because this is how negative 1 looks like. I mean, it's just all ones, and that would be negative 1. And let's do the 0 here. The 0 is, of course, if we look at the most significant bit, it'll be, 0, so we don't have to do anything. We don't need to swap it. We don't need to add 1. So that would be just 0. Let's look at this one. And then we can talk more about the 0 in a little bit. But let's see this one. This one, of course, we have 1 here, which means it's negative. Let's swap. So if we swap, we would end up with 0, 1, 1, 1. And then we want to add 1. And notice that something very interesting happens. When we add 1 to this, we end up with the same sequence that we started with. So if you take this sequence, if you swap it, and then you add 1, you actually end up with the same sequence, which would be, in this case, 8. This is an 8. Because remember, do you see this unsigned treated as unsigned? When I say treated as unsigned, that means you want to take this number and treat it as a positive number. So this was kind of intentional on my end to kind of say specifically unsigned. So if you were to treat this as unsigned, that would be 8. And of course, here we would have the negative 8. And this is kind of interesting because negative 8 was outside the range when we talked about sign and magnitude, and 1's complement. However, in 2's complement, we can actually get to -8. -8 is a number that you can represent in 4-bit 2's complement. You cannot do 8 because you can't do 8 in, if you can't do 8, if you want to do something that looks like this, clearly that's going to be negative because the most significant bit is 1, so that's not 8. In this case, in 2's complement, this is not 8. Of course, in unsigned, yeah, that would be 8. But if you start with 2's complement and you start with this representation, that's not going to be 8. For you to determine what that is, you have to swap and add 1, convert to unsigned, and add the negative sign. So it would be -8. So that is -8. So there only is 1 0 and 2's complement. That's a very good observation, Anthony. So what Anthony is thinking about is if -8 was taken, if -8 is going to take a shape, then right now we don't have 2 shapes, even though we haven't talked about 0 and -0 in kind of depth yet. But it would be safe to assume that because we're using, -8, which is going to take a single shape, we're not going to have 2 representations for 0. And that's correct, Anthony. We're going to have actually 1 0. Now, here's an interesting exercise. So first of all, let me tell you, before we do the exercise, let me tell you the range of a 4-bit 2's complement is actually between -8 to 7. So we have 8 negative numbers, and these are between -1 to -8, or -8 to -1 if you want. And we have 7 kind of positive numbers, and that would be 1 to 7. And we have kind of 1 0. And in this case, positive means kind of above 0 and negative means below 0. The 0 in this case, we're not treating it as positive nor negative. Maybe I should say 7 numbers between, just to make sure that we're not 1 and 7, and let's say 8 numbers between -1 and -8. And of course, or let's say from 1 to 7, say from -1 to 8, -8. And we have 1 0 here. And if you add up those, 8 plus 7, that's 15, plus 1, 16, and that's perfect because 4 bits give us 16 combinations anyway. I mean, it kind of adds up perfectly. So I have 1 0, 7 numbers from 1 to 7, 8 numbers from -1 to -8. Now, the interesting exercise that we're going to do is to come up with -0. So we know how we come up with -5, right? We start with 5, we swap, we add 1. Do you remember that? I don't want you to forget that. I mean, it's okay if you forget it now, but after you practice and study it, you really shouldn't forget that. So if I tell you how does -5 look like, you're going to say, we start with 5, we swap, we add 1. Now let's try to do the same thing with -0. Let's start with 0. Let's try. It's an exercise. Start with 0, add 1. Excuse me, start with 0, swap, then add 1. So how does 0 look like? Well, start with 0. Well, that's going to be 1, 2, 3, 4. Let's swap. If you swap all of that, you end up with 1, 1, 1, 1. When you add 1, why did I say 0? You add 1. Adding 0 doesn't make sense. You add 1 here. When you add 1, you actually end up with 0, 0, 0, 0, assuming that you get rid of the carryover that extends the most significant bit. If you take 1, 1, 1, 1, and you add, 1 to it, you actually end up with 0, 0, 0, 0, and there's one that extends the most significant bit that we get rid of in this case, and we end up with those. So right now, just something to clarify here. Right now, we're not doing 1's complement addition or 2's complement addition. We're simply following the procedure. And typically when you add 1, that one, if you add 1 and you end up with one that extends the carry, extends the most significant bit, which is really only this case, you can get rid of it in this case, and you would end up with that, which is really what you started with. So essentially what I'm showing you here is there's no such thing as -0 in 2's complement, because even if you start with 0 or 0, 0, 0, 0, and if you try to get the negative of that by, flipping and adding 1, you would end up with 0, 0, 0, 0. So there's only one 0 in 2's complement, and that would be that. Okay, so the last piece of information that I want to share with you, and you can study that home, is that if you do addition in 2's comp, addition will be correct every single time, and you don't have to take the one, say the carryover that extends the most significant bit, and add it to the result. You don't have to do that. It'll actually work without doing anything extra. You can just discard or get rid of the one that extends the most significant bit. Let me show you a few examples here. Let's look at those examples. So first of all, what's the value of this one? Let's do that together. What's the value of this one in decimal? Of course, this is 2's complement. Do you want to guess? I know we're going over time, but I think it would be better if we just finish this and tomorrow we start with something new. So what is this one? Is -3 in 2's complement or 1's complement? Are you sure this is -3 in 2's complement? Okay, okay, so this is 1's complement. How about 2's complement? So right now we're going to do things in 2's complement. Here, 2's complement. Let me make this bigger. Okay, so what is this in 2's complement? Okay, it's -4. So remember, if it's a negative, and that's okay, because all of that is new stuff. So I understand that it's easy to forget the intricate details here, but I'll tell you what we would do. We would look at the most significant bit. If it's 1, we swap, add, convert. So when you swap, you end up with 1, 1, 0, 0. You add 1, you end up with 0, 0, 1, 0, and that would be 4. You convert that to decimal, that would be 4, and you add the negative sign, that would be -4. Does that make sense, Anthony? Are you? Okay, perfect. How about this one? What is this one? This one should be slightly easier. What do you think of this one? So this one is a positive number. So what do we do when we have a positive number? Seven. That's right. So that would be 7. So if you add -4 to 7, you should end up with 3. And we know how 3 looks like, right? 3 looks like that. Now, of course, if you do the addition, you will notice that you end up with 1 here. Let me just do that. So 0 plus 1, there's a 1. And then 0 plus 1 here, there's a 1. 1 plus 1, there's a 0. And then there's a 1 that goes here. 1 plus 1, there's a 0. and there's a 1 that goes here, which we ignore. Okay, so let me make sure that we understand this. When you're adding in 2's complement, and if there's a 1 that extends the most significant bit, if there's a carryover, if there's a 1 carryover that extends the most significant bit, we just ignore it. We don't have to do anything with it. This is 2's complement addition. In 1's complement, we needed to take this 1 and add it to the result, which was kind of annoying. But in 2's complement, we don't have to do that. So 2's complement is a really good representation. First of all, we don't have 2 zeros, which is amazing. When we do addition, we don't have to worry about this carryover and adding it to the result. Is that good? Okay. So let's do this one. In fact, I'll let you do all of that. I'll let you do this and this and that. Just one thing to keep in mind here, and maybe I should show you that here. Can you tell me what this number is? Let's start with this number. What is this number in decimal? What's this number in decimal? Okay, that's good. That is 6. How about this number? Are you sure it's 7? What's this number? Okay. Oh, sorry. How are we getting 6? You're absolutely right. I apologize. I did agree with you, Grace, but I shouldn't have agreed with you because this is not 6. This is 4. I guess I think maybe it's time for all of us to take a break here. But this one is 4. Thank you, Anthony. That's 1. The value of this one 1. The value of this one's 2. The value of this one's 4. So that's 4. And now I understand why you came up with 7, Grace, because you thought this one is 6. Okay. So what is this one in this case? I mean, what is this one in the right case? What's the value of this one? 5. That's good. So 4 plus 5 is 11. Is 11 within the range of 4 bits 2's complement? I said 11. It really is probably time for us to take a break. It's 9. Is 9 within the range of adding of 2's complement, 4-bit 2's complement? No, and because of that, you can still do the addition, but the number that you're going to end up with is not going to be 9. It's impossible to end up with 9 because you cannot fit 9 in 4-bit 2's complement. You just can't. So you can still do the addition, but of course the number that you're going to end up with is not going to be 9 because you're going to end up with only 4 bits, and it's just impossible to represent 9 in 4-bit 2's complement. Just something to keep in mind. And here you're going to have similar situation. These two, if you add these two numbers, you're going to actually end up with a number. If you look at this number, I'm not going to do it here, but I'll let you do it home. If you look at this number, and if you look at this number, and if you try to do the addition in decimal, just like how we did 4 plus 5, you will end up with a number that does not fit in 4 bits. So it just doesn't fit in 4 bits. Let's see. Anthony's saying, do we end up with unsigned binary 9? That's correct. In this case, yeah, we do end up with unsigned 9. But of course, because it's 2's complement, it wouldn't be 9. It would be kind of a negative value. No, it's not a lucky. It's not a lucky. If you add 2 kind of positive numbers, you always will end up with the correct answer in unsigned. And that's another thing that I think we should think about, and yeah, and try to kind of make sense of. I think this is a good exercise. You don't have to master numbering systems, but you can learn a lot, and you can kind of gain insights on how those numbers work. So we can spend, another 2 hours talking about them and looking for patterns. But and it's great. I think that's why it's really good to ask these questions and try to kind of, again, answer those questions until you feel that you investigated kind of enough about the topic. I can tell you that you don't have to, again, master numbering systems, but if you feel that this interests you, then I would say, yeah, you should certainly pursue the answers to those questions. All right, so I think we should stop here. We went over time, and I think because we were trying to rush things, we started making silly mistakes, all of us, including myself. So maybe next time we'll try to stick to our scheduled time. We're done with numbering systems. I'm going to post the slides. That's going to be exam material, kind of first exam material. And tomorrow, we're going to probably start with MIPS. We will certainly start with MIPS. Maybe we'll do a quick review. But after that quick review, we'll be doing MIPS tomorrow. So, all right, I'm going to stop the recording here. Do we have a Zoom session Friday? Yes, we will have a Zoom session Friday. Even though there's an exam, we'll still have the Zoom session. Yeah, we'll have the Zoom session. All right, let me stop recording.